Hello viewers, I am Dr. Debashis Bhowmick from the beautiful orange city of Nagpur, working as a professor in Jhulelal Institute of Technology, Nagpur. I am here today to make you all understand the concepts of hazard, risk, vulnerability and a bit of an assessment of risk. For a common man without having any background of science and technology, these three words seems to be very synonyms. But technically speaking, there is a difference between all these three important key words used in measuring, assessing disasters, natural disasters I am talking about. My flow of today's lecture will be like, we will start with concept of hazards, moving ahead with the concept of risk, a bit of assessment of risk, and finally I will end with the concept of vulnerability and its types and some methods to stop it. We start with hazards, a very common term in our day-to-day life. We have seen so many commercial items written over it, hazardous. Talking in perspective of disaster, the definition of hazard goes like this: it is a threat or a future source of danger or a very natural event which has a potential to cause harm to the elements of physical environment. From the people's perspective, hazard may cause death, injury, disease or maybe stress. As far as human activity is concerned, it may be economic, it may be educational. From property point of view, it may be damage of property, economic loss of the nation. From environment point of view, pollution, loss of amenities, these are some of the causes of hazards. Few examples of hazards, natural hazards to be precise, like earthquake, volcanic eruptions, cyclones, landslides, absence of rain leading to drought, excess of rain leading to floods. Some man-made hazards like chemical manufacturing plants near human settlements, incorrect agricultural techniques. These are some of the examples which may cause hazard. If we need to classify hazards in three, on broader perspective, there are three ways I think in which we can classify hazards: natural hazard, quasi-natural hazard and technological hazard or man-made hazard. Natural hazards such as earthquake, floods arise from purely natural process in the environment, in which directly common people, they don't have any control. Moving on to the second term, that is quasi-natural hazards such as smog, which I think we all know it is a combination of smoke and fog, very hazardous to human life, or desertification arise through the interaction of natural processes and human activities. From these photographs, I think it is very clear about the natural hazards and quasi-natural hazards. Technological hazards, in the present scenario, I think this is a point to be looked upon, a man-made hazard. Hazards such as toxicity of pesticides to fauna, accidental release of chemicals or radiations from nuclear plants, these arise directly as a result of some human activities. In the screen you can see some disastrous result because of these hazards. At this point, I would like to brief the viewers about this smog, which is named after a very great city, London, named as London smog. At this point of time, I would like to take my viewers to 1952 and tell you about something about London smog. Now, London smog took away around 4,000 lives, and it was a result of burning of coal just to overcome the cold, and because of low temperature, humid environment and smoke it mixed up to give away this smog. Because of this smog, so many casualties happened. And I think, talking about India, our capital Delhi is marching towards the same. Every year we can hear so many incidences because of this smog. Every winter all the flights are delayed. Every winter the trains are delayed because of smog. This is just the beginning. If we don't take proper care, I think Delhi smog incidents is not very far. Talking about Fukushima, Japan, I think the world knows what happened because of some hazardous leakage from nuclear plant there. So I think our own country, India, serves the example as an example for all the three types of hazards: natural, quasi and technological. Moving ahead with the secondary type of hazards, the hazards which are correlated with some primary hazards, natural hazards, like building collapse. It may be due to earthquake, it may be due to flood, it may be due to tsunami, dam failure because of excessive rain, it may be fire, hazardous material spills, interruption of power, water supply, communication, transportation, waste disposal, landslide, soil liquefaction, tsunami, water pollution, etc. But I think in most of these cases, the human intervention plays a very important role. So now I will be speaking something on the influence of human intervention. Although human can't do much to change the incidence or intensity of most of the natural phenomena, but they have a very important role to play in ensuring that natural events are not converted into disasters by their own actions. Let me introduce disaster at this point. It is a very serious disruption or destruction of or loss of material or environment which the affected community is unable to cope up using its own resources. It impacts and affects the way in which we live. There is a close similarity between hazard and disaster, as well as a difference as well. Disaster, from the above definition, it becomes apparent that it is incorrect to refer natural disaster, since natural phenomena in themselves are not disasters unless they impact negatively on populated areas. There is no such thing as natural disaster, but disaster often follows natural hazards. The definition which I have given earlier, from that it becomes very apparent that it is incorrect to refer to natural disasters, since natural phenomena in themselves are absolutely not disastrous unless they impact negatively on populated areas. A tsunami at an island which is not populated, we don't bother about it. But the moment that tsunami starts influencing, affecting the livelihoods, then it becomes disastrous. There is a distinction between hazard and disaster. A natural phenomena is not hazardous until it poses a threat to human life, property, infrastructure or the environment. If it goes beyond this, adversely affecting the livelihood and economy, and if resources are not within the means of the people to manage the situation, then it can be termed as a disaster. Quasi-natural hazards, in which human intervention is always there. It can increase the frequency of occurrence and also severity of natural hazards. I can give an example. When the toe of a landslide is removed to make room for settlement, the earth can move again and bury the settlement. It may also cause natural hazards which were never existed before. For example, volcanoes erupt periodically, but it is not until the rich soils formed on their eject are occupied by farmers and human settlements, and they are considered hazardous. The extreme case of destructive human intervention into an ecosystem is desertification, which is by its very definition is a human induced natural hazard. What is most important in hazard is the return period. The human time scale, majority of hazards have return period, the time when again we expect it to come back. For example, a 5-year flood, a 50-year flood and a 100-year flood. The frequency is measured in terms of hazards recurrence interval. The recurrence interval of 100 years of flood suggests that in any 1 year, the flood has 1% chance of occurring. Such extreme events have very low frequency but very high magnitude. That means the hazard which happens in long time has a very high magnitude of occurrence. This means that an event considered being a 100-year flood would cause severe damage compared to a 5-year flood. I think for this return period of hazard, India serves the best example because we have so many states which are absolutely flood driven. Earthquake is very popular in some of the areas of India. So, India on that sense is quite hazardous from these natural phenomena. Hazards, identification and assessment. This is the last part which I will be dealing on hazards. If you are living in an area exposed to multiple hazards, for each hazard ask yourself some questions and try to answer them. They could give you a reasonably good indication of the threat posed by the hazard of the area in which you live. The questions are like, could this hazard affect the area you live? How often does it pose a threat? For example, once every 5 years or once every 10 years? Is this hazard significant threat there? What is a close estimate of the population size that could be affected by this hazard? Give a rating, very high, high, medium or low. What is expected duration of the hazard? What is the expected damage from the hazard event? Give also a rating, very high, high, medium or low to gauge the hazard. What is the expected intensity of impact expected? Can the effect of the event be reduced? Which is of course a very debatable question, but if you could answer all these questions in a proper manner, if you could gather many answers to these questions from the community which you are living in, I think the identification and assessment of hazard can be done very easily by yourself as well. So, dear viewers, after hazard, let us move on to the next topic, and that is risk. It is usually associated with the human inability to cope up with a particular situation. In the context of disaster management, it can be defined as probability of harmful consequences or expected loss, death, injury, damage to property and the environment, disruption of economic activity or social systems. Disaster risk is widely recognized as the consequence of the interaction between hazard and the characteristic that make people and places vulnerable and exposed. Disaster risk, a very important term to understand. It results from the complex interaction between development process and that generate conditions of exposure, vulnerability and hazard. This part I will deal a bit later as well in form of a triangle. Disaster risk is therefore considered as the combination of 4 things: severity, frequency of hazard, that is number of occurrence, number of people and assets exposed to hazard, vulnerability to damage. These are 4 major disaster risks which can be considered. Characteristics of disaster risk: forward looking, the livelihood of loss of life, destruction and damage in a given period of time. Dynamic, it can increase or decrease according to our ability to reduce vulnerability. Invisible, it is comprised of not only the threat of high impact events, but also the frequent very low impact events that are often hidden in their nature. Unevenly distributed around the earth, hazards affect different areas, but the pattern of disaster risk reflects the social construction of exposure and vulnerability in different countries. The same hazard may be looked upon in a different way in different countries. Emergent and complex, many processes including climate change and globalized economic development are creating new interconnect risks. So, to make us understand the extent of risk, Crichton has given us a risk triangle, which is very easy to understand. This equation in this triangle is very easy to understand by a very common man as well. As the equation suggests, risk is the product of hazard, exposure and vulnerability. In the triangle, there are three sides and each side represents these three important terms in disaster. Hazard on one side, vulnerability on the other side, exposure on the other side. And in the intersection of these three sides, I think there is risk. So, risk is decided by the combination of all these three factors. If any one of the side increases, the risk increases because the area of the triangle increases. So, I think Crichton has given us a very good and illustrative way of understanding and measuring the value of risk involved in the occurrence of any event. Next question is, how do we measure disaster risk? And before that, I would like to ask you, why do we need to measure a disaster risk? A very simple answer: disaster risk is to be measured just to reduce the risk. Unless and until you measure the risk, how you will be able to reduce it? So, for reducing disaster risk, it is required to identify the risk first, understand it, the nature of the risk, and then assess it so as to formulate a mechanism to reduce the risk. We can measure disaster risk by analyzing trends of previous disaster losses. These trends can help us to make strategies and gauge the effectiveness of disaster risk reduction. We can also estimate future losses by conducting a risk assessment. Talking about risk assessment, a detailed risk assessment considers the full range of potential disaster events and their underlying drivers and uncertainties. It can start with the analysis of historical events as well as incorporating forward-looking perspectives. Integrating the anticipated impacts of the phenomena that are altering historical trends such as climate change. We may also consider rare events that lie outside projections of the future hazards, but are based on scientific knowledge which could offer, means predicted events. These are the points which are very important for risk assessment. There are other components of assessment as well, like hazard, which we have already talked about. It is also evident from these pictures that hazard, exposure and vulnerability, these are the key aspects to assess the risk. Exposure means the stock of property and infrastructure exposed to the hazard, and it can be included socio-economic factors as well. Vulnerability accounts for the susceptibility to damage of the assets exposed to the forces generated by the hazard. Vulnerability estimate the damage and the consequent losses respectively, and or the social cost, for example, number of injured, homeless and killed generated by a hazard according to the specific exposure.
Risk means different things to different people in different contexts. It is the product of likelihood and consequences, that is how likely a person is to be exposed to a hazard, and the consequence, that is how bad the outcome will be. It is measured so that appropriate actions can be taken as a step to suppress negative outcome. There is a road, and let us assess the risk involved in crossing the road. There is one bicycle on the road every 10 minutes. The bicycle is the hazard, but the likelihood that a person may collide with the bicycle is quite low, as the frequency of bicycle commuting is low. Further, if at all collision occurred, consequence of it would be relatively minor. Thus, the overall risk is low. Let us take another case. There are many bicycles on the road. The likelihood that a person may collide with the bicycle is high, but if collision occurred, consequence of it would be still be minor, so the overall risk would be medium. If there is one truck on the road every 10 minutes, here truck is the hazard, but the likelihood that a person may collide with the truck is quite low, as the frequency of the truck commuting is low. Further, if at all collision occurred, consequence of it would be severe. Next, if there is heavy traffic of trucks on the road, the likelihood that a person may collide with a truck is high, as the frequency of the truck commuting is high, and the consequence of it would be high too. So the overall risk would be high. Probably a person may never want to cross the road. Now, let us talk about risk matrix. A risk matrix is a matrix that is used during risk assessment to define the level of risk by considering the category of probability or likelihood against the category of consequence severity. This is a simple mechanism to increase visibility of risks and assist management decision making. In other words, a risk matrix uses information about consequences and likelihood to determine the overall risk. Risk matrix comprises of the grid with likelihood on one side and consequences on the other, graded from low to high. The color-coded area on the grid, as shown on the screen, depicts the area of low, medium and high risk. As in case 1, where there is one bicycle commuting on the road every 10 minutes, the likelihood that a person crossing the road may collide with the bicycle is low. Moreover, if at all collision occurred, consequence of it would be relatively minor. Thus, the overall risk is low. As in case 2, where there are many bicycles commuting on the road, the likelihood that a person crossing the road may collide with the bicycle is quite high, but consequence of it would be relatively minor. Thus, the overall risk is medium. As in case 3, there is one truck commuting on the road every 10 minutes. The likelihood that a person crossing the road may collide with the truck is quite low, but the consequence of it would be severe. Thus, the overall risk is medium. As in case 4, where there are many trucks commuting on the road, the likelihood that a person crossing the road may collide with a truck is quite high, and consequence of it would also be severe. Thus, the overall risk is high. Now, let us talk about some advantages of risk matrix. They are a practical and easy to use tool which helps most organizations in many circumstances to promote robust discussion, provide some consistency to prioritizing risks, help keep participants in a facilitated risk workshop on track, focus decision makers on the highest priority risks, present complex risk data in a concise visual fashion, for example, bubble charts. They can be very effective for getting timely results in a facilitated risk workshop and for presenting the data. Now let us talk about limitations of risk matrices. Risk matrices can correctly and unambiguously compare only a small fraction of randomly selected pairs of hazards and can assign identical ratings to quantitatively different risks. It can mistakenly assign higher qualitative ratings to quantitatively smaller risks. It can result in suboptimal resource allocation, as effective allocation of resources to risk treatments cannot be based on the categories provided by risk matrices. Categorization of severity cannot be made objectively for uncertain consequences. Assessment of likelihood and consequence and resulting risk ratings require subjective interpretation, and different users may obtain opposite ratings of the same quantitative risks. Some examples of risk matrices are shown on the screen.
With this, I come to an end with the concept of risk and its assessment. Moving towards the next topic, and that is vulnerability. As I said, the words susceptibility and vulnerability are very close. It is the conditions determined by physical, social, economic and environmental factors or processes which increase the susceptibility of an individual, a community, assets or system to the impact of hazards. For example, poor design and construction of buildings, inadequate protection of assets, lack of public information and awareness, high levels of poverty and education, limited official recognition of risks and preparedness measures, etc. causes vulnerability. I would like to explain the term vulnerability. Vulnerability is the diminished capacity of an individual or a group to anticipate, cope up with, resist and recover from the impact of a natural or a man-made hazard. The concept of vulnerability is relative and dynamic. It is most often associated with poverty, but it can also arise when people are isolated, insecure and defenseless in the face of risk, shock or stress. People differ in their exposure to risk as a result of their social group, gender, ethnic and other identity, age and other factors. Vulnerability may also vary in its form. Poverty, for example, may mean that housing is unable to withstand an earthquake or a hurricane, or lack of preparedness may result in a slower response to a disaster, leading to great loss of life or prolonged suffering. To determine people's vulnerability, two questions need to be asked. The first one, to what threat or hazard are they vulnerable? And the second one, what makes them vulnerable to that threat or hazard? We need to develop a counteraction mechanism, and which requires reducing the impact of the hazard itself where possible through prediction, warning and preparedness. Building capacities to withstand and cope up with hazards. Tackling the root cause of vulnerability such as poverty, poor governance, discrimination, inequality and inadequate access to resources and livelihoods. Speaking about potentially vulnerable groups, displaced populations who live their habitual residence in collectives, usually due to a sudden impact disaster such as an earthquake or a flood, threat or conflict as a coping mechanism and with the intent to return. Migrants who leave or flee their habitat to go to new places, usually to abroad, to seek better and safer perspective. These groups are quite potentially vulnerable. Re-returners, former migrants or displaced people returning to their home. Specific groups within the local population such as marginalized, excluded or destitute people. Young children, pregnant and nursing women, unaccompanied children, widow, elderly people without family support, disabled person are potentially very much vulnerable. So with this, we have come to an end of this part of the lecture, and I think it is the time to wrap up what we have discussed till now. We started with the concept of hazard. We have defined it, given some example, classifications like secondary hazards, natural hazards, influence of human intervention, how it can increase the risk of hazard, differentiated between hazard and disaster. We have seen some assessment parameters, return period, which is a very important parameter to measure hazard, identification of hazard and its assessment. Second part was the concept of risk, definition, disaster risk, characteristics of disaster risk, seen a beautiful triangle, Crichton's risk triangle, risk management, risk assessment. And finally, to conclude, it was the concept of vulnerability, its explanation, its counteraction and some potentially vulnerable groups. Thank you so much.